we're going to shade the solutions of 4 different systems of inequalities, all related to inequalities with the same variable, but different inequality signs. So in part A, I'm going to solve each of these inequalities for y, getting y is less than or equal to x, and y is greater than or equal to the opposite of x plus 2. So first of all, I graph the line y equals x. Part of that line will be a boundary for the region that we will end up with. So y equals x goes through the origin. It also goes through, let's see, how about 5, 5. So there's our first line. Go back and choose the line tool. And y equals the opposite of x plus 2 has y-intercept 0, 2, and x-intercept 2, 0. So there are our 2 lines. And now we're wanting to find a region that is on or below the first line, the dark black one, and on or above the second, the gray one. And so this is going to be on the right-hand side of our grid here, and that will be the region that is shaded for part A. I'm going to use a test value as a check, and this time I'm going to test with a point that I can see is in the shaded region 5, 0. And notice that 0 is less than or equal to 5, and 0 is greater than or equal to the opposite of 5 plus 2, which is negative 3. So it does check. So now we'll go down to part 2, or B. And this time, we're going to have y is greater than or equal to x. And we're going to have y is less than or equal to the opposite of x plus 2. And it ends up that I've already drawn this graph. Notice that the first line I drew through 0, 0 and 6, 6. The second line I drew through 0, 2 and 2, 0. Now, I'm looking for points that are above y equals x at the same time as below y equals the opposite of x plus 2, or on those lines. And so I think my shading is correct. I'm going to use as a test value this time the ordered pair 0, 1. So 1 greater than or equal to 0 is correct, and 1 less than or equal to the opposite of 0 plus 2, which is 2, is also correct. So our test value seems to be correct, and all points in that region or on the boundaries will satisfy the inequality. going down to part C. In this case, we have y will be less than or equal to x. And y will be less than or equal to the opposite of x plus 2. So we draw the lines that have now become familiar. And this time, we want points that are below y equals x and also below y equals the opposite of x plus 2. So this time, the fill region is this bottom quadrant created by the two lines. And I can check with a test value. You can use a different test value if you want. I'm going to use 1, 0. So 0 is less than or equal to 1, and 0 is less than or equal to -1 plus 2, which is 1. So 1, 0 checks. And we have one more to do here. Part D. In this case, y is going to be greater than or equal to x at the same time that y is greater than or equal to the opposite of x plus 2. So above both of our lines is where we will be shading. And this time, let me try the ordered pair 0, 4. Four is greater than or equal to 0. 4 is greater than or equal to 0 plus 2. So 0, 4 checks. So we actually had a system that described each of the 4 quadrants created by the intersection of the two lines y equals x and y equals the opposite of x plus 2.